Welcome to this explainer. When we look back at the moon landing today, it feels like this guaranteed triumph, right? Like it was always meant to happen. But today, we're going to strip away that feeling of historical inevitability. We're dropping you right back into July 1969. Picture this, the stifling, humid heat of Cape Canaveral, the freezing, claustrophobic depths of space, and the sheer geopolitical tension of a Cold War rivalry that was pushing human engineering to its absolute breaking point. Because, as you're going to see, on the eve of mankind's greatest achievement, disaster was literally just a heartbeat away. So imagine the shock if the world knew this one massive secret. Just 3 days before Apollo 11, a Soviet robot had already launched. While a million people were packed onto the Florida coast watching American astronauts launch toward history, the Soviet Union had quietly fired off a massive Proton rocket from the Baikonur Cosmodrome. Their goal? To completely steal America's thunder. We're talking about two rival spacecraft about to share the exact same lunar sky. Section 1. A secret space race, the parallel countdown. We're really looking at a high-stakes geopolitical chess match here, a battle for global supremacy disguised as scientific exploration. The contrast in their approaches is just wild to think about. On one side, you have the Soviets rushing this automated robotic drill, Luna 15, into the void. And on the other, the Americans are betting everything on a colossal 15,000-kilogram human-crewed machine, the lunar module Eagle. It was literally a race between the sheer speed of Soviet automation and the adaptable, calculated risk of an American human pilot. Now, behind the scenes, Soviet leadership was dealing with multiple catastrophic failures of their own massive crewed rocket, the N-1. So they pivoted to a desperate, highly strategic backup plan. They hid Luna 15's true purpose behind a vague cover story about studying lunar orbit. But the real objective? Land, drill up to 200 grams of lunar soil, and blast it back to Earth just before Apollo 11 could return with its own hand-collected samples. It was a calculated bid to completely shatter global attention. But here's a crazy detail. In this super rare moment of Cold War cooperation, born purely out of necessity, Soviet officials actually shared their orbital data with NASA through astronaut Frank Borman. They had to, just to make sure these two multi-million-dollar machines didn't literally crash into each other in orbit. Section 2. Forging the Lunar Vanguard, the human element. To really grasp this, we have to look at the relentless timeline of Soviet technological shocks that forced the U.S. into action. When Sputnik launched back in 1957, it wasn't just some beeping metal ball in the sky. To Americans, it was terrifying proof that Soviet rockets could deliver nuclear weapons across the globe. That fear mobilized the entire American democratic industrial base, funneling billions into NASA. And all of that effort culminated on the stifling morning of July 16, 1969. Imagine three men sitting on top of a 363-foot Saturn V rocket, which was basically a giant bomb packed with 6 million pounds of highly explosive, freezing liquid propellant. At the very tip of that spear were three highly experienced veterans. You got Neil Armstrong, the famously ice-cold test pilot, Buzz Aldrin, the brilliant systems engineer, and Michael Collins managing the insanely complex orbital mechanics up above. But here's the thing. Despite all their combined expertise, they were flying into the absolute unknown. Armstrong himself admitted there were just too many things they didn't even know could go wrong. The psychological burden of that kind of uncertainty, it's almost impossible to imagine. Section 3. The simulation that saved Apollo. July 1969. Okay, to really understand the crisis that's about to unfold, we have to look at this hidden turning point just days before launch. On July 5th, a simulation supervisor named Richard Coos intentionally threw a curveball into a practice landing. He injected a cryptic computer error, a 1201 program alarm. Well, the guidance officer, Steve Bales, didn't recognize the code, so he aborted the simulation. Coos was absolutely furious. He reprimanded the team and demanded they learn exactly what every single computer alarm meant. And thank goodness he did, because if Coos hadn't failed them in that simulation, the actual Apollo 11 mission would have undoubtedly been aborted. Stung by that brutal reprimand, a 24-year-old computer engineer named Jack Garman went back to his desk and got to work. He meticulously wrote out a cheat sheet detailing every possible obscure program alarm, noting whether it was safe to keep flying or not. He literally just tucked that single piece of paper under the glass on his console desk. He had absolutely no idea that in just a few days, the fate of the entire Apollo 11 mission would rest on that one page. Section 4. Alarm 1202, the Descent Crisis. Put yourselves inside the lunar module Eagle for a second. You're 6,000 feet above the moon, falling at blistering speed. The descent engine is roaring, and suddenly, things begin to violently unravel. Now, the Eagle's guidance computer was an absolute marvel for its time, but it had strict limits. Because Buzz Aldrin had chosen to leave the rendezvous radar on for safety, just in case they had to instantly abort and find Michael Collins in orbit, erroneous signals started flooding the system. This junk data ate up 15% of the computer's precious processing time, pushing the hardware right to the absolute brink of failure. Right at 6,000 feet, a yellow caution light winks on the panel. Armstrong radios Houston, his voice incredibly tight. Program alarm, it's a 12:02. This exact, totally obscure code flashes on their display. It completely distracts the crew at the exact moment they needed to be looking out the window for a safe place to land. Back on Earth, you can imagine hearts just dropped. But what is truly fascinating about this moment is that this 1960s MIT-designed software wasn't actually failing. Not at all. That 12:02 alarm meant executive overflow. The computer was actually smart enough to recognize its own limits. It was intentionally rebooting itself to shed that irrelevant radar data so it could focus exclusively on the one thing that mattered, keeping the descent engine firing and the astronauts alive. Deep in mission control, Steve Bales hears the alarm and spins to the back room. Jack Garman glances down at that handwritten list trapped beneath the glass on his desk. He spots the 12:02 and tells Bales it's safe, as long as it doesn't become continuous. Bales instantly relays this to Capcom Charlie Duke, who tells the breathless astronauts, "We're go on that alarm." Guys, this was arguably the most high-stakes split-second judgment call in the entire history of human exploration. But wow, the drama was far from over. Because they had lost so much precious time dealing with the computer, Armstrong realizes they've completely overshot their smooth landing zone. The computer is now flying them blind, directly toward a crater surrounded by massive car-sized boulders that would instantly shatter the lander on impact. Tension skyrockets. Armstrong grabs the manual control stick, skimming this incredibly fragile ship over deadly rocks. And then, down in Houston, they call bingo fuel. That means Armstrong has exactly 20 seconds to find a safe patch of lunar dust and land this thing, or he has to trigger the abort sequence and end the mission entirely. Section 5. The Eagle and the Crash, July 1969. So, as Armstrong desperately hunts for a safe landing spot, literally balancing the Eagle on a pillar of fire with mere seconds of fuel left, our parallel countdown overhead reaches its violent conclusion. It really shows you the razor-thin line between triumph and disaster. On July 20th, Armstrong manually threads a needle and lands the Eagle safely. He and Aldrin go on to collect 21.5 kilograms of lunar rocks. But meanwhile, the Soviet Luna 15 probe is struggling with the rugged lunar terrain and delays its landing. Finally, on July 21st, it starts its descent, but its attitude is completely wrong. The probe plummets and violently crashes into a mountain in Mare Crisium at 130 meters per second. Luna 15's transmissions abruptly cut out after just 237 seconds of descent. And this crash happened roughly 2 hours before Armstrong and Aldrin fired their ascent engine to head home. The robotic Soviet probe yielded 0 samples, proving in just the most dramatic way imaginable that rushed automation could not substitute for the situational awareness, the visual processing, and the sheer survival instinct of a highly trained human pilot. Section 6. A Giant Leap's Legacy, the Aftermath. The events of those few days in July 1969 didn't just plant a flag in the dirt. They permanently altered the trajectory of the Cold War and the entire future of space exploration. The success of Apollo 11 was an absolutely unmatched victory for American industry, fulfilling John F. Kennedy's mandate. But the legacy is a lot more complex than just winning a race. The Soviet Union, totally demoralized by their N-1 rocket failures and the Luna 15 crash, eventually abandoned their crude lunar ambitions entirely. And slowly, that deadly geopolitical rivalry actually began to thaw. It paved the way for real orbital cooperation, culminating in the 1975 Apollo-Soyuz test project, where former rivals literally shook hands in space. I want to leave you with a final thought, something you should definitely take away as we look toward our future among the stars. Apollo 11 proved that smart software is absolutely vital, but without Neil Armstrong's manual override to dodge that boulder field, and without Jack Garman and Steve Bales' very human judgment in mission control, the landing would have been an utter disaster. So, as our modern spacecraft become increasingly reliant on artificial intelligence and full automation, we have to ask ourselves, will algorithms ever truly replace the instinct, the courage, and the split-second adaptability of the human pilot staring down a field of boulders? Thank you for joining me on this explainer, and keep questioning the history you think you know.